So thanks for coming. If you didn't see my talk earlier, then I'll just go over very briefly what it was about. So we did a demo of how you can take a small embedded core in Codasip Studio and customize it to run an AI workload a little bit faster. So we're not making an accelerator or anything, we're just implementing some custom instructions to accelerate a workload on a small core. So very briefly, Studio is Codasip software product which allows you to either design a processor from scratch or customize an existing processor, and it will generate you...
Tom,
oh.
Yeah, we're not saying what you're saying.
Oh, oops. Sorry, I thought I was in. Let me figure it out. So yeah, Codasip Studio is the software product. You can design a processor from scratch or customize an existing one, and it will generate you an SDK, an RTL, and things to help you with verification, etc. So when you profile your application in Studio, it will identify some common instruction sequences. So here's a couple from our AI workload. So it's a mul and an add, multiply and accumulate, and loading byte with a post increment. So this df0 will just means that it's using the same register. So we know that this pattern is coming up loads and loads in our program, and it's making up about 26% of the total cycles of the execution. So it's really easy to derive from this some custom instructions that you might want to implement. So we've got a Mach32 instruction, which multiplies two sources and adds a result to accumulator and a load post increment, pretty self-explanatory. And these instructions will be used by the SDK automatically. So they get kind of applied in just like this to your code. And the result of these two instructions alone is like a 13% reduction in cycles per inference and a little bit less power too. But this wasn't all we did. In the talk earlier, we covered all the instructions I added, and the result was about a 1.6 times speed up with a 30% reduction in power. And all of that came with a pretty small area increase when you factor in the size of the core to start with. So I'll just show you how you can add a custom instruction in Studio. So when you profile in Studio, you get something that looks like this, and these are the sequences I was talking about. So this is for the whole program, not just for inference, but you can see the patterns I mentioned appearing here. And so from there, you can define a instruction-accurate definition for your instruction. And so, for example, the load post increment looks like this. It's really easy. There's just some setup stuff. You define an assembly format for it, a binary format for it, and the code to design it is really similar to C. So we're literally just reading a register to get the address and loading that address and adding an offset to it to do the post increment. Something a little bit more complicated, like the SIMD instructions I added. Oops. Defined like this. So again, it's still really simple to do relatively complicated instructions for something that might happen in a core like this. Just loading two sources and expanding the two halves of one out to 16 bits each, and then adding something to each of those lanes and concatenating to get the result. So that's, I think I'm about at time now, but hopefully I've just demonstrated how easy it is to add a custom instruction in Studio. And the result you can see is a pretty significant cycle reduction. So here's before and after. And you can see that the compiler did actually use all our instructions, and they're working. So yeah, if anyone wants to talk about this or my talk earlier, then come and find me, and I'd be happy to give you some more info. Cheers.